Hello students, welcome back to my channel. Today we are going to study about a very interesting topic of physical science of class 9th. Okay, so are you ready? Okay, by the way, how are you all? I hope you all are doing well. Okay students, so let's begin. Now, you can see some pictures on your screen. Yes, the first picture and then the second picture. First, second. Yes. Just tell me your observation. Okay. So basically there are two kind of particles. First one is red particle and the second one is blue particle. So in first picture you can see they are completely mixed with each other. And this is the second picture. You can see what you can see. You can see they are slightly mixing. Red particle get mixed with blue particle. Okay, and the third image, what can you see? They are not mixed yet, they are different. Okay, the line of red particle is different and the line of blue particle is different. And in the last fourth image, what's happened? Yes, they are mixed but quite scared or like basically spread all over the direction in all over the place. Okay, so just tell me, mixing of one particle into another particle is known as what? Like one particle get mixed into another particle and then that is known as, it is related at today's topic. You can also guess at today's topic. Yes. So that is known as diffusion. Our today's topic is diffusion. Okay students. So now I am going to give you some formal definition of diffusion. And for this I have also added picture you can see at the side. Okay. So what do you mean by diffusion? The spreading out and mixing of a substance with another substance due to motion of its particle is called diffusion. Okay, so what else is said, like the spreading out or basically mixing of substance from one particle of substance get mixed with another particle of substance due to motion of its particle. As you can see, like suppose I'm sitting in this room, okay, and I'm breathing. So while breathing, what I'm breathing? I'm breathing air. In air, what? Oxygen. So it means in my room, in my surrounding, the particle of air is present. So in the same way, the particle of one substance and the particle of another substance, they get mixed, but due to their own motion, okay, no other party, due to their own motion. So that is known as diffusion. And the rate of diffusion increases. What? The rate of diffusion increases on increasing the temperature of the diffusion substances. Okay, you have also observed this, like I'm giving you some example, okay, that you have observed in your daily life. Suppose you have taken a gas stove. On this, just bring a container filled with water. Okay, so when you just lower the flame, what happened? The formation of bubbles in that vessels, in that water vessels, is slightly low. Okay, but when you bring that flame into high, what happened? The formation of bubble increases. Dip, 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 dip. This kind of things. Okay, so the same thing applicable on here. What? The rate of diffusion increases. Like when we increase the temperature, then the rate of diffusion, the mixing of one particle into another particle, is become very high. Okay. So now tell me, what do you mean by diffusing substance? Sorry for my bad throat. Yes. So tell me, what do you mean by diffusing substance? Basically, one substance get mixed with another substance by its own motion, that is diffusing substance. And how can we increase the temperature? By what? By heating. Okay, by heating we can increase the temperature. So, from the above experiment, we conclude that phenomena of diffusing cell, okay, phenomena of diffusion tells us that the particle of matter are constantly moving. Okay. So, as you can see in this picture, you can see this long test tube. Yes, and there are brown fumes present only at the bottom. But after some time, what happened? These fumes get shifted to upper part of this test tube. It means that particle is moving constantly. Okay. So now students, just tell me what are the different states of matter. We have already discussed this thing in our previous lectures. Yes. What are the different states of matter? Matter can be solid, liquid and in gaseous state. So basically there are only three physical states: solid, liquid and gaseous. Okay. So the next one. Now this is an activity time. Okay. So what you see in this slide. First one is matchbox and the second one is agarbatti. Okay. What happens? Suppose if I just light this agarbatti with the help of this matchbox. What happens? Yes, just tell me. Fumes are coming out from the agarbatti. Is it so? Yes. So fumes are coming out. So basically that means diffusion in gases. So when we burn an agarbatti in one corner of the room, its fragrance spreads in the whole room because the particle of gases produced by whom? By burning of agarbatti moves rapidly in all direction and mix with the moving particle of air in the room. Okay. So it's shown that the particle of matter are constantly moving. They can't stay on the same place. They are constantly moving and they are not lazy. That's why they are constantly moving. Okay. You can also see there are some, picture over there, like the gas particle moves enable us to smell the intense stick from the distance. You can see when we burn this stick, then the fumes comes in our nose. Okay. So students, just tell me, like give some examples of diffusion in gas in your everyday life. From where will you like get this kind of examples? Or have you have also observed it? Okay, you also feel this. Where? Okay, for hint I am telling you, like when our mom is cooking food in kitchen, then the smell of food, we can smell that food even if we are not present in the kitchen. Okay, that can be also example of diffusion. Okay, and what else? The second one is the smell of perfume spread due to the diffusion of perfume vapor into the air. So these are the several examples in our day-to-day life. Like for perfume, you can say that if you are sitting in this room and suddenly one person across from you, okay, so and they are putting some strong kind of perfume. So what if person is gone, but still you can smell the perfume. This is due to the because the the particle of the perfume get mixed with the particle of the air. So that's why we can smell the perfume. Okay. Now it's quiz time. So the question is, gases have a tendency to mix with each other. Okay. So this phenomena is known as what? Chemical. Option A, chemical reaction. Option B, diffusion. Option C, effusion. And the last option, explosion. So what will be the correct answer? Diffusion. Yes. Yes. So the correct answer of this question is diffusion. Okay. Now moving ahead. Okay. So we have studied about diffusion in gases. Now it's time to diffusion in liquid. Yes. Just tell me what you have observed in this picture. There is a beaker. You can see beaker filled with water or filled with liquid. Okay. What else? We have put it some drops of what? Some drops of blue solution, or we can say iodine solution, anything. Okay. Or a color solution in this beaker. What happened? You can see Now the color is spreading, and after some time the color is spreading in all over this container. So this means diffusion occurs in liquid also. Okay. Yes. Now, diffusion in liquid is slower than that in gas. So, the rate of the diffusion in liquid is slower than the gas, because we know the particles that are present in gas, they are highly movable. Okay, but in water or in liquid, the particle is moving, but as compared to gas, it's quite slow. So, that's why the rate of diffusion is slower than gases. Okay. So, this is because the particle in liquid moves slower as compared to the particle in gases. For example, the spreading of purple color potassium permanganate into water on its own is due to diffusion of potassium permanganate particle into water. Okay. Now, the spreading of ink in water on its own is due to diffusion of ink particle in water particles. Okay, students. So, this means that diffusion can also occur in water and the rate is slower than air. Okay. Air, we can say gas. Now, it's quiz. It's a question time for you. Okay, you have to tell me. When we put some crystals of potassium permanganate in a beaker containing water, we observe that after some time whole water has turned pink. This is due to A option boiling, B option melting of potassium permanganate crystal, C option sublimation of crystals, or the D option diffusion. Yes students, what will be the answer? Just tell me. Yes, it's diffusion. Okay, so now we are going to study about diffusion in solid. We already discussed about diffusion in liquid and diffusion in gaseous. Now we are going to study diffusion in solid. So you just see this picture that is shown in this slide and just tell me what you observe. Yes, suppose you can assume that this is the particle A and this is particle B. What's happening? Yes, just tell me. Particle getting mixed, but not so completely. Okay. So let me tell you why. So it will quite difficult to clean the board afterwards. This is due to the fact that some of the particle of chalk have diffused into the surface of blackboard. Okay, you have seen in your school time, or we can say still you can see, like once your teacher is writing on blackboard. Okay, so after his writing, once you rub the board, then it's very hard to remove the chalk particle. Why so? Because the particle of chalk get diffused with particle of what? Particle of blackboard. Okay. So that's why you are rubbing, but still it's very hard to remove that. Okay. So diffusion in solid is very slow process. Okay. And the particle in solid do not move from their fixed position. Like the solid particles get attached or get seated, get stick at their own position. These are very hard. They are in fixed position. They can't like move from here and there. Okay. So, due to lack of appreciable movement in the particle of solid, the diffusion of solids in solid is rare. So, diffusion from solid particle to solid particle is very rare. It can't be so easy. Okay. Now, the question time. Okay. So, the question is, which of the following diffuses fastest and which is the slowest? Yes, the fastest diffusion. Solid, liquid or gas? Which one? Yes, students. It's gas. Okay. And the slowest one? It's solid. Okay. Good. Now, just tell me, do you know the common unit of temperature? Like temperature is measured in when you are having high fever. Oh, I'm having fever. So, you know, doctor like measure our fever with the help of thermometer and the reading comes in what? Yes, the temperature of, yes, that is Celsius. Okay, degree Celsius. And there are SI unit of temperature, that is Kelvin. Okay. So the common unit of measuring temperature, like if you want to measure melting point, boiling point or any other things, so we can measure in which unit? In degree Celsius. Okay. And the SI unit of measuring temperature is Kelvin. For temperature it's Kelvin, SI unit. So this is used by scientists mainly for research work. Kelvin is not so common that common people are not using it. This is only used for research work. Okay. Okay. Moving ahead. Now fill in the blanks. Okay. You have to just pause this video and just read this statement and just write it down. Okay. So what is this? Degree Celsius is denoted by which symbol? Yes, just tell me. Let me write. Degree Celsius is denoted by degree and then C. Okay. And Kelvin is denoted by which symbol? Is denoted by K. Okay. The melting point of ice on Celsius scale of temperature. Guys, it's melting point of ice on Celsius scale of temperature. That is 0 degree Celsius. Okay. Yes. And the boiling point of water on Celsius scale of temperature is, water starts boiling on which temperature? On 100 degrees Celsius. Okay. Yes. And students, do you think there is any relationship between Celsius and Kelvin? Yes, just think about it. Can Kelvin related to Celsius? Because they both are used for measuring, temperature. Okay, so let me tell you the relationship between the Celsius and Kelvin scale. Okay, so the melting point of ice on the Celsius scale is what, students? It's 0 degrees Celsius, and on Kelvin scale it's 273. So the relationship between these is 0 degrees is equal to 273 Kelvin. 0 degrees Celsius is equal to how many Kelvin? 273. And the relation between Kelvin scale and the Celsius scale can be written as, like, if you want to solve the question, you can solve the question on the basis of this equation. Okay, temperature on Kelvin scale equals to temperature on Celsius scale plus 273. You just add on 273. Okay. Okay. Next. So there are two questions. Now you have to solve this question by your own. Okay. I already told you about the relationship between Kelvin and Celsius. Now you have to solve this question. Yes, students. Okay. Let me also solve you. So what is the relationship between, like, what we have to do? The Kelvin scale temperature is equal to what? Degree scale, degree Celsius plus we just add to 273. So this is already given that what is the temperature on degree Celsius? It's 27. We just need to add 2, 7 and 3. So after adding, what we will get? We get 300. Okay, 300 Kelvin. Yes. Now question number 2. Convert the temperature of 300 Kelvin to Celsius scale. So first, just write the equation. Kelvin scale value equals to degree Celsius plus 273. Now in this we have given 300 Kelvin scale value and we have to calculate degree Celsius. So just write as it is plus 273. Now just minus 273 from where? From 300. Okay. So it is equal to degree Celsius. So the answer we will get 27 degree Celsius. Okay, students. Okay, just practice this type of question. It's very important. Okay. Yes. Now, recapitulation part. So, students, today we have learned about diffusion in different particles. Now, you have to define what you mean by diffusion in your own word. Basically, it's mixing of one particle to other particles. Okay. Now, question number 2. Arrange the following according to their diffusion rate. Like, the rate of diffusion high in what? Gas. After that, liquid. After that in solid. So just arrange all of these things according to their rate. And question number 1, this is practice question for you. You can practice it. Just pause this video and write down this question in a notebook. Convert the following temperature to Celsius scale, 293 Kelvin as well as 470 Kelvin. Okay. And the question number 2 is convert the following temperature into Kelvin scale. First we need to convert Celsius scale, and the second question convert into Kelvin scale. That is 270 degree, and the second one is 373. Okay students? Okay, now your homework time. So, in homework, what else? Question number 1. Explain why the diffusion of solid in another solid is very slow process. You just have to explain it. And question number 2. Name two gases of air which dissolve in water by diffusion. What is the importance of this process in nature? Okay, just write down the answer. And the third one is activity time. So what do you have to do? You have to prepare a model to demonstrate moments of what? Moments of particles in solid, liquid and gases. For making this model, you will need a transparent jar, a big rubber balloon and a piece of stretchable rubber sheet. Okay. Or a string, few chickpeas or black gram and dry green peas. Okay, you can take any kind of pulses. And how to make it? Just you can also see the picture present over there. Okay, you have to just put the seed into the jar. After that, sew the string to the center of rubber sheet and put some tape to secure it properly. After that, stretch and tie the rubber sheet on the mouth of the jar and your model is ready. So now run your finger ups and down the string by first tugging at it slowly and then rapidly. Okay students? Okay. So thanks for watching my video and we will meet in next lecture. Bye.